In this section, we're going to look at the graphs of a function. First of all, if you've got the graph of a function, or a graph, period, how do you determine if it is a function? We use the vertical line test. So looking at these four pictures, which ones are a function and which ones are not? So the first one, we draw vertical lines. If one vertical line hits more than once, then it's not a function. In this case, they all just hit once, so we have a function. For the second one, draw a vertical line. Here we can already see that it hits more than once, so we do not have a function. And the third one, vertical line, they all just hit once, so we have a function. And last, draw a vertical line. Even if we draw it over here, it only hits once. But if we draw it anywhere and it hits more than once, then we do not have a function. Use this graph to answer the following questions. So, first it says f of negative 3. Now remember, this means if the x value is negative 3, what is the y value? So we look over here where the x is negative 3, we see that there's a y value at negative 3. So f of negative 3 is negative 3. What about f of 0? So where is the x value 0 on this graph? Up here at 2. So f of 0 is 2. For part C, it says find all x for which f of x is negative 1. Well, what does that mean? F of x is negative 1. That's where the y value is negative 1. So if the y value is negative 1, what x values do we have? So y value of negative 1, the only one is right here, where the x value is negative 1. So the x value of negative 1 is your only solution. And then the next one says find all x for which f of x equals 1. So where is the y value 1? Well, we would want to say right here, but that's an open dot, so we can't use that point. But right here, it looks like the y value is 1, and here the x value is 2. Determine the x-intercept. Where does it cross the x-axis? Well, here's the x-axis. It doesn't cross. So we can say that there are no x-intercepts. Then it asks us to determine the y-intercept. So, where does it cross the y-axis? Right here. So it crosses the y-axis at 2 or at the point 0, 2. To determine the domain of f. So remember, the domain are the x values. So starting from the left, we've got an arrow going to the left here. So we know that we've got an arrow going to the left. And then moving towards the right, there's no breaks. Now, yes, there's a break here, but not in the x values, because even though this one is open, for the same x value, we have a closed. So there's no breaks for the x value. So the domain is negative infinity to infinity. The range, what are the y values? Well, we've got an arrow going down, and it's going until we get to negative 1. And then there's a gap until we get to 1 and going up. So we've got negative infinity to negative 1, and negative 1 is included, so we put a closed bracket, unioned with, okay, this is how we interpret the break with interval notation, and then we're starting at 1 and going to infinity. Now, I left a bracket or a brace off there because we're going to talk about that. So, because of this open dot, we would think we need to put just a parenthesis because we're not including 1. But this little spot right here is including 1. So that means we will use a bracket. For example 3, find the zeros of this function. Well, what is a zero? A zero is the x-intercepts. It's just another way of saying x-intercepts. Another way of saying it would be solutions. The solutions are the x-intercepts or the zeros of the graph. So what are the zeros of this graph? Well, there's one at 0, 0. Here's one at pi over 2, 0. Another at pi 0. Here's one at 3 pi over 2, 0. And at 2 pi, 0. Now you see why they're called the zeros, because all the y values are 0. Determine if this point is on the graph of f. To do that, we plug in the point and see if we get a true equation. So f of x, remember that's the y value. So the y value is 3/4, so we plug that in for f of x. And then our x value is 1, so 1 plus 3 over 1 plus 4. 1 plus 3 is 4, and 1 plus 4 is 5. Guess what? This is not equal. That means that the point 1 3/4 is not on the graph. Here, if x is 2, what is f of x? So what we're doing here is we're finding f of 2. We just plug in an x of 2, and we get 5, 6. So f of 2 is 5, 6. What is the point where x is 2? Well, the point would be 2, 5, 6, where the x value is 2 and the y value is 5, 6. See, if f of x is 4, what is x? So this time, f of x is 4. So we plug in 4 for f of x. And then we have to solve for x. So multiply both sides by x plus 4 to get rid of the bottom of our fraction. And we're going to distribute here. Okay, get the x's over on the left. So subtract x from both sides, and we have 3x. Get the other values over on the right, so subtract 16 from both sides, we have negative 13. Divide both sides by 3, and we have negative 13 over 3. Or if you want to change that to a decimal, it's approximately negative 4.33. And that's the conclusion of this section.